Hi guys, thank you for watching my previous video. So today we are looking at a new chapter called Linear Law. So without further ado, let's turn to the next slide. So over here we have a question. The variables x and y are related in such a way that when y minus 3x is plotted against x squared. So over here, as you can see, the horizontal axis is x squared, the vertical axis is y minus 3x, and a straight line passing through 2, 1, and 5, 7. So you see this straight line as well. So part 1, we are asked to find y in terms of x. So what we learn in Amaths. So in Amaths, we learn the equation of a linear equation. So the general form of a linear equation is y equals to mx plus c. And in Amaths, our vertical axis is our y, our horizontal axis is our x, with m is our gradient and c is our y-intercept. So let me write the word vertical nicely. So this is what you have learned in Amaths. And now in Amaths, we will make use of this same concept. But over here, please take note. We have a big y and we have a big x, while our m and our c remains. So in this case, our horizontal axis is our x squared, and our vertical axis is our y minus 3x. Therefore, if you sub these two in to this big Y equals to m big X plus c, you will get y minus 3x equals to m x squared plus c. So basically, we learn what we learn in Amaths, and we make use of the concept in Amaths and we apply it in Amaths. So this is called linear law. And what else you learn in Amaths? To find the equation, or rather to find the linear equation of a straight line, you will take y minus y1 equals to m bracket x minus x1. And this same concept can be applied in Amaths. But over here, we have our big Y, we have our big X. While our big Y is our vertical axis, our big X is our horizontal axis. And we just need to take one pair of coordinates. And our vertical axis is y minus 3x. So let's take 2, 1 to be our x1, y1. So our y1 is 1, therefore minus 1 equals to m bracket our big X is x squared minus our x1 here is 2. Therefore, you form this equation. And with this equation, right, what we need to do? We need to find our gradient of this straight line in this graph. So our m is 2. So therefore, let's sub in our m equals to 2 into this equation. And you should get y equals to 2x squared plus 3x minus 3. And this is the answer to part 1. And now, part 2, the values of x when y equals to 62. So what we need to do, we just need to sub in our y equals to 62 into our answer in part 1. And you should get 2x squared plus 3x minus 65 equals to 0. And this is obvious. And you should be able to see that this is a quadratic equation. And if you go and factor it out, you will get 2x plus 13 bracket x minus 5 bracket equals to 0. And therefore your x equals to 13 over 2 and x equals to plus 5. And we have completed this question. And I hope it isn't very hard for you. So the main point here is we make use of the concept we learned in Amaths for linear equation. We use the concept here. So as you can see, I've highlighted the concept and how we can make use of it in Amaths. And now we are given another question on a new slide. So over here, the question says the table below shows experimental values of two variables x and y, a table of x and y, and it's known that x and y are related by an equation of the form xy equals to a plus bx. So let's write down this equation. And you should see that if we divide by x on both sides, what we get? We get y equals to a 1 over x plus b. And this looks like our general form for linear equation in Amaths. So the general form in Amaths is big Y equals to m big X plus c. And as you can see, I'm trying to match term by term. Our a is our gradient, our b is our y-intercept, our 1 over x is our big X, and our y is our big Y. And therefore, we just need to plot a graph with y as our vertical axis and our 1 over x as our horizontal axis. And with our a is our gradient, b is our y-intercept in that graph. So I have tabulated a table with the x values and its y values and its corresponding 1 over x values in the table on the right. So with these values of y and values of 1 over x, I am able to plot the equation above. So our horizontal axis is our 1 over x, our y axis is our vertical. In fact, our vertical axis is our y. So let me label the graph before I proceed. So without further ado, when our y is when our 1 over x is 0.5, our y equals 38. I have marked 1 point. And when our 1 over x is 0.25, our y equals to 21.3. And I have marked it as well. When our 1 over x is 0.17, our y is 18.8. Another point. Okay, let's proceed. When our 1 over x is 0.13, our y is 13.1. Let's mark one more point. Okay, last point. When our 1 over x is 0.1, our y equals to 11.5. So you can see I have marked all the points out. Our job next is to link these points up to get the best fit line. Okay? So I hope you get a clearer picture by now what we are doing here. So let me get a drawing tool and let me link up all these points as best as possible. And by the way, not only you have to link up these points, you also need to extend this line and make sure it cuts our vertical axis, because the y-intercept is the value of b, and we need to find that. So I have darkened my line, plus I think I have drawn a best fit line. So what I need to do now, part 2. Using a suitable scale, draw the graph for the given data and use it to estimate the value of A and B. So A is the gradient and B is the y-intercept. So in fact, we can actually read it off the graph for our B value. But let's go and do the value of A first. But before that, after drawing the line, you should label this line. And this line is y equals to A 1 over x plus b. Our b is 4, as you can clearly see. The y-intercept is 4. So let's take 0, 4 as one coordinate. And let's take the other coordinate as 0.5 and 38. So with these two coordinates, we are able to find our gradient, and that will be our value of A. And you should get 3.4 over 0.5, which gives you which gives you 68 or 6.8. So now we have come to this last question of the chapter. The question says, another table shows some experimental values of two variables x and y, and they are related in the form xy equals to p square root x to the power 3 plus q square root x. So let me copy the equation down first before I continue. So with this equation, and you should be always looking out for an equation which is similar to your general form equation. Big Y equals to m big X plus C. So how are we going to do that? Let me manipulate the equation first. So after manipulating the equation, you can see that we can actually divide by x on both sides. Or rather, this question is not very straightforward. So let me divide by x first on both sides. So my left side has y, and my right side should be equal to p x to the power half plus x to the power minus half. And let me convert the x to the power half into square root x to the power minus half into 1 over square root x. So clearly, we can proceed further by divide by square root x on both sides. And therefore, your left side is y over square root x equals to p plus 1 over square root x times square root x. Square root x times square root x is x. And I have neglected the q. Let me add it in. And therefore, this is the final equation. And it looks like the general form. Big Y equals to m big X plus C. And you can see that our big Y here, or the vertical axis, is y over square root x. And our horizontal axis is 1 over x. Our m is our q, our c is our p. And therefore, I've tabulated a table with values you need for you to draw this graph. So let's start. So when 1 over x is 1, we get y over square root x 1.1. When 1 over x is 0.5, we get y over square root x equals to 2.4. Another point. 1 over x equals to 0.33. Y over square root x equals to 2.83. Okay. Hold on for a while. because I'm still looking for my 2.83. So I will go up and I should mark the 2.83 when 1 over x is 0.33. Next, when 1 over x is 0.25, we get 3.05. Last but not least, 1 over x is 0.2, I get 3.18. Okay, so I have marked out all the points, and your job is to link up all these points, and please extend your line so that it cuts the vertical axis, and you should see that it goes out of bound. That's why, but I can somehow guess what is the value of my y-intercept. But when you draw your graph, you shouldn't have this case. Okay, so due to the limitations of my graph here, I apologize for it, but you should extend your line and it should cut our vertical axis. So I have already plotted the graph of y over square root x against 1 over x. And we are asked to estimate the value of P and Q. And now it should be easy, right? Because let me count what is our y-intercept here. So my y-intercept should be about 3.7, and that should be the value of our P. But before that, let me darken this line, and please do not forget to label your line. So the line is y over square root x equals to P plus Q 1 over x. Okay. So I have found my value of P, which is my y-intercept. And now we are asked to use the graph to estimate the value of x when y over square root x is 2.7. Therefore, when y over square root x is equals to 2.7, my 1 over x is 0.39. And therefore, my x is actually 1 over 0.39. So my x is 2.56. And we are asked to add a suitable straight line to this graph and find the solution of the simultaneous equations. So what I have done above, I have simplified the first equation, and now I have another equation, xy equals to 2 square root x. And what it means here, for equation 2, xy equals 2 times square root x, what you need to do is you need to manipulate or convert this equation into a form which gives you your vertical axis is y over square root x and your horizontal axis is 1 over x. So I divide by x on both sides, and I get y equals to 2 times 1 over square root x. And once again, I divide by square root x on both sides again. So I get y over square root x equals to 2, 1 over x. Therefore, I have my vertical axis as y over square root x and my horizontal axis is 1 over x. And this should be easy now. So what I need to draw is, I need to draw a straight line which gives me a gradient of 2 in this graph. So pretty easy. 0.2, I should get 0.4. When I 0.4, I should get 0.8. 0.6, I get 1.2. 0.8, I get 1.6. So please wait for me to mark out all these points. So as you can see, I make some mistakes, so let me redo it. let's redo again. So I need to draw a line which gives me a gradient of 2. And it should start from 0. Because over here there is no intercept. So it should start from 0. That's what it means. So 0.2 I get 0.4, the first point. 0.4 I get 0.8. 0.6 I get 1.2. And 0.8 I get 1.6. And as you can see, my 0.6 is off, but I will correct it. Okay? So never mind. Let me join all these points with a straight line. And this straight line should give me a gradient of 2. And this straight line is the suitable straight line that can help us find the solutions of the simultaneous equations, equation 1 and equation 2. So remember, so I am moving this point back. So now all the points are correctly placed. And let me darken this line. And I should use a different color. Okay, I use red. And after drawing a line, you should label this line. It's always a good habit to label all your lines. Okay? You don't label it, you get penalized. You label it, definitely you won't get penalized. And so, what I have here is 0.8, comma 1.6 for the intersections. And what it means 1 over x equals to 0.8 and y over square root x equals to 1.6. And therefore, with this, I can continue to find my x. My x is actually 1 over 0.8, which gives me 1.25. And once I get my x, I just need to sub it into y over square root x equals to 1.6. And this should give me my y. As you can see, I have sub it in. So my y is, so please punch your calculator and see what you get for your y. And your y is 1.79. Okay? So in fact, for two simultaneous equations like this, they might be very complicated if you use any other method, but for simultaneous equations, we have 3 methods: elimination, substitution, and graphical method here. And of course, you can think of the last method as you can use your calculator if your calculator is powerful enough. And I think I have missed out my value of P and my value of Q. So let me write it down. So my value of P is 3.7, which is my y-intercept. And my Q is my gradient. So to find gradient, you need to find, first you need to obtain 2 sets of coordinates. So I will take 1.1, oh no, I will take 1. I did not write it clearly, so let me erase and rewrite it again. So over here, let me take 1 and 1.1 actually to be my first set of coordinate, and I will take my 0, 3.7 as the other set of coordinate. So 3.7 minus my 1.1 actually. Okay, over 0 minus 1, and you should get 3.6 over minus 1, and you should get minus 3.6 instead. Okay, so I will correct it, and we have come to the last slide of the session, and hope you have enjoyed it. See you. Bye.